In this video, we're going to look at variance and standard deviation of a data set. We're actually going to break this objective up into a couple videos for purposes of time. Also, take a look at some computer simulations to model what we'll talk about in this objective. So, first, we're going to talk about what's known as deviation from the mean. So the deviation from the mean refers to how far a data value x is from the mean. And it's found by taking that data value and subtracting the mean from it. So if our data value is above the mean, then it's going to be larger than it, which means a big number minus a smaller number is going to be positive. Whereas if the data value is below the mean, then it's going to have a negative answer. So in that case, would have negative deviation from the mean. So let's say our data value is 5 and our mean is 10. 5 minus 10 is negative 5. Our value of 5 is below the mean. That's a negative deviation. So example 2, find the mean for the following prices of gas. So we have $3.25, $3.40, $3.21, and $3.38. So we add them all up. We get $13.24, and then divide by, let's see, there's 1, 2, 3, 4 gas prices. So $13.24 divided by 4 is a mean gas price of $3.31 per gallon. So we can think of the mean as a balancing point for our data set. So here are our 4 gas prices, and the mean is the fulcrum, $3.31, and it balances out our data set. We have a couple that are below the mean, and we have a couple that are above the mean. So each data point has a deviation or distance from the mean. So these two on the right are going to have a positive deviation because they were above the mean. These two on the left side are going to have a negative deviation because they're below the mean. So you could think of the mean as like the origin, and then to the left, like on a number line, we have negative values. To the right, on a number line, we have positive values. But in this case, we have negative deviations on the left, positive deviations on the right. So calculate each point's deviation from the mean. So we want to figure out how far each of these points are from the mean in terms of, are they to the left or are they to the right? So our price of $3.25, if we take $3.25 and subtract $3.31, we are 6 cents below the mean, so negative 6 cents. And then same thing with 340, we take 340 minus 331, we get 9 cents above the mean, so positive 9 cents. And then do the same with the other two data values. We'll get negative 10 cents for $3.21, and we get positive 7 cents for the $3.38. So our two data values that are below the mean have negative deviations, and our two data values that are above the mean have positive deviations. So now let's get an idea of how much on average the data is spread out from the mean. So we calculated these deviations, and on average, how far are each of these 4 points away from our mean gas price of $3.31? So we can do that by calculating the mean of the deviations we got in the last example. So again, just looking at these deviations we got, if we take the mean of these deviations, we'll get an idea of how far on average our data spread out from the mean. So example 4, find the mean of those deviations in gas prices. So once again, here are our 4 deviations. We're going to find the mean of those 4 numbers. So when we add them all up, we get 0, and 0 divided by 4 is 0. So on average, there's no spread from the mean. And it turns out this is always going to be the case because the total for the positive deviations is always going to equal the total for negative deviations. So if you think back to the picture where the mean is the fulcrum and everything was balanced, it's balanced because the total deviations on the left, this case would be negative 16 cents, is going to equal the total deviations on the right, which in this case is positive 16 cents. So no matter what we do, the sum of the deviations from the mean is always going to be 0 no matter what. Well, that doesn't really help us with figuring out how far on average each of the points are if we're always going to get 0. Sometimes we'll have points that are really far away. Sometimes we'll have points that are really close, but we don't want them to cancel out each other, the negatives and the positives. We want to be able to do something about that happening. And there's one of 2 things we can do to take care of those negative deviations adding up to the opposite of the positive deviations. One is to take the absolute value of all the deviations. So if we take the absolute value of the negative deviations, they're positive now. So we'll have, I believe it was a positive 6 cents and a positive 10 cents now. Or we could take the squares of the deviations, because remember, when we square a negative number, it becomes a positive number. Now, in terms of calculations, while the mean of the absolute values of the deviations has its own uses called the mean absolute deviation. So if you took the absolute value of the deviations and then found the mean of that, you're finding the mean absolute deviation. In terms of calculations that we're going to be using, that are more algebraic, it's better to work with the squares of the deviations instead. So example 5, we're going to take each of these values and square them, and then find the mean of those squared deviations. So when we square them, negative 0.06 squared is 0.0036, 0.09 squared is 0.0081, and then we could do the same with negative 0.10 and positive 0.07. We get 0.01 and 0.0049. So now notice we're not going to have any negative deviations canceling out the positives anymore. And when we find the total here, we get 0.0266 for adding up the squared deviations. And then dividing that by 4, we get a mean of 0.00665 for the mean of these squared deviations. All right, so in the interest of time, we're going to end this video here, but we'll pick up with this in the next one. So thanks for watching. I'll see you next time.